Morning everyone, and it's good to see that so many of you have found the way through this first session, and I have difficulties with the microphone first, so it's not working. Okay, my slides. So now we start. My talk will be about web services, with a particular emphasis on how web services could be used in the language industry. I will first start with what are web services, and as the name implies, web services has to do with the World Wide Web, and it is a specific implementation approach that covers the technical details of a service-oriented architecture, which today is the strategic enterprise paradigm for the realization and maintenance of business processes that span a wide and large distributed systems. So, because it is an IT solution, a service is an IT representation of a particular business process. And my talk will cover first some details about service-oriented architecture. So I won't go into the technical details, but I will give you an overview so that you have an idea of what's behind service-oriented architecture, and then I will go to the basics of web services and how web services interrelate with service-oriented architectures. I will then give you an example of an implementation of a successful web service implementation in the field of travel and leisure, and then I will try to map this onto a language technology and a language industry scenario. I will introduce two initiatives that have dealt with interoperability in a service-oriented language technology scenario, and I will also introduce the so-called representation and state transfer implementation issue. That is another way of implementing services. With some recommendations, I will end my presentation. So let's first see what are the service-oriented architecture basics. SOA consists of three major technical concepts: the architecture, the infrastructure, and large systems. The architecture in the form of services. The infrastructure accounts for interoperability between the different systems involved in this environment, and the large systems are responsible for the loose coupling to reduce the dependencies between systems. The architecture comes into play because distributed processing is not only a technical detail, it changes everything in your company. Introducing a new functionality is no longer an aspect of assigning a certain task to a specific department. It is a combination of multiple tasks for different systems, and these systems and the involved teams have to collaborate very closely. Therefore, you need clearly defined roles and responsibilities. You have to define your services in a classified system. So there might be simple services like, for example, retrieving and storing customer data, but there might be also very complex services such as the business process of handling a customer product order. The infrastructure, in terms of a so-called enterprise service bus, enables the interoperability between the services involved in this scenario. It makes it easier to distribute the different business processes over the multiple systems, and this also includes multiple platforms and technologies. Loose coupling is needed because business processes are distributed over multiple backends. So you can imagine you have databases, and if we go to the language industry sector, you might think about translation memories, terminological databases, and so on. And loose coupling is needed to distribute this effectively over the services, and it is important to minimize the efforts you need for modifications and to prevent failures. Now, service-oriented architecture with web services. And web services refers to collection of standards, and here we have the buzzword again, standards. Remember yesterday? They define the protocols that are used to communicate and the formats of the interfaces that are used to specify services and service contracts. Essentially is what I term the gang of five for web services. We have XML, and this includes XML schema and XML namespaces for models, formats, and data types. We have HTTP as the transport protocol, SOAP as the high-level protocol for exchanging web services data. We have UDDI, which stands for Universal Description, Discovery, and Integration for managing the web services, and WSDL for the description of the web of the services interfaces. And here you see, because in the beginning I mentioned in the name or in the term web services we have web, and HTTP is used as the transport protocol. Later we will come to another notion of HTTP where we look at the transfer capabilities of HTTP. WSDL is a key characteristic of web services, and the others are more or less optional, such as UDDI, which in principle and today is rarely used. WSDL has a layered structure, and this comprises a signature for the service name and the service parameters, and binding and deployment details are for protocol and location of the web service. As you can imagine, this looks quite straightforward, but there are also challenges. Challenges comprise, on the one hand, the description files, the WSDL structure, as well as the web services itself. So I have introduced only 5 standards for web services, but today we have approximately 150 standards covering all aspects of web services. So you might think about security issues, authentication issues, and all that stuff. Too many standards might hinder interoperability, and we will also see in this session what we can do about it. Another thing is the enterprise service bus, where you also need in different environments proxy servers, because the internet protocol that is used as a transport protocol, HTTP, must be also worked over, for example, firewalls. So there are some challenges in web services and in particular in the web service description language. But what would be the alternatives? Here we might end up with proprietary solutions, or we would reinvent the wheel again. One nice example that most of you have already used when you travel when you book your travel, when you rent a car, these are the Amadeus web services, which in most cases internet travel services use in their backends so that you get the services you want for managing your travels. So whenever you use a booking facility on the internet or you rent a car on the internet, behind the doors might be the Amadeus web services. And now let's see how this translates into the language industry. And maybe some of the veterans in this room remember the 2001 LRC conference, which was under the header E-localization. At that time, 2001, everyone puts an E in front of a certain name, and so E-localization was the theme of the 2001 LRC conference. And at that conference, there was an interesting talk given by Bill Luby of IBM, and he talked about web services and globalization. He introduced web services as a possibility to employ web services in the language industry, and he showed how the language industry could benefit from web services. At that time, web services were, so to say, brand new. The work on web services started in the late 80s and in the late 90s, and so everything was not mature enough, and this led eventually to the creation of an OASIS group for the development of so-called translation web services. And some of you might have heard of translation web services. In 2007, the OASIS group published a draft of these TWS. However, the translation web service didn't get much adoption in the language industry, and this might be due to the fact that during this time between 2001 and 2007 there emerged a new kind of system on the language industry market, which were the translation management systems. And on the other hand, the translation web services didn't cover all the business processes in the localization ecosystem. And some of these features are shown here on my slide, where you have a lot of, let's say, systems in quads, and you have to see how the responsibilities and roles are distributed in this ecosystem. Let's look at a simple example, a round trip in a localization supply chain, where we have a translation and localization buyer, a language service provider, which could be a multi-language vendor. We might have a single language vendor or an individual translator, and they exchange data, and they also have to communicate effectively in order to have an efficient round trip. And if you look at the different tasks, I will go through all the stages in the round trip, and you have different tasks and responsibilities. We start with a localization manager, and you see that the localization manager has to mark up and extract the content that needs translation and so on. That's pretty much what you know, how the processes are organized in the localization and translation industry. And this goes over to the multi-language vendor, to the individual translator, and then back to the multi-language vendor, and back to the localization and translation buyer. You know these processes pretty well, and the challenge here is how do we communicate effectively between these systems, the roles, and the tasks they have. As you can imagine, these systems could be situated somewhere in the cloud, and yesterday we also had talks about crowdsourcing, and this translator in the middle could be also a crowd that is managed via a certain service environment. To solve the communication and data exchange problems, in 2010, 2 initiatives have started to attack these problems. And this was, on the one hand, the initiative Interoperability Now, which was initiated by my co-author, Sven Andre. And on the other hand, we had the Linport initiative, which were independently set up. But they had the shared goal of providing a solution for the interoperability problem based on the so-called container metaphor, which we borrowed from the shipping industry. So Interoperability Now focuses on automation and translation only at the moment. So a little bit similar to the translation web services we have heard about. And the Linport project focuses more on the human consumption of the data flow. And they also include the complete stage from authoring to publishing. But both share the vision of the container metaphor. The 2 initiatives have agreed to jointly employ the Translation Interoperability Protocol package, which I will introduce in a minute. And this Interoperability Protocol package was developed by the Interoperability Now initiative, and it has been already successfully demonstrated to the localization community at the Localization World this year in Paris, and yesterday we also had a webinar, a gala webinar, where the Linport and Interoperability Now solutions were introduced. And the next speaker in this session will also show one of the systems that was involved in the gala webinar. At the Localization World, demonstration systems from Medtronic, Andrea G, Kilgrave, and again XTM were involved. So, what is the core concept of the Interoperability Now protocol? It comprises core task types, a manifest for stating metadata, and a payload specification. At the moment, the actual payload, which is the data that is relevant for the translation and localization process, is XLive doc, and the Interoperability Now initiative has also streamlined a bit the current XLive 1.2 version, and this version is now named XLive doc. The streamlining concerned, on the one hand, the markup of terminology and the inclusion of a UTX-inspired terminological glossary, as well as some syntactic and semantic streamlining, which mainly concerned syntactic ambiguities in XLive. In the manifest of the package in form of metadata, we state the creator of the package, the task that is involved, and a description of the actual content. That means a description of the payload. At the moment we have only task types for translation, as I mentioned, and here we distinguish between a request or a response. We have three task types: translate strict bytext, translate generic bytext, and translate native format. And fourth one, which doesn't have to do with translation, but with the preparation of specification for a translation project. Translate strict bytext is the most restrictive task type, and it specifies that you have to use XLive doc, and all the others are more or less free in what payload they are using, except translate generic bytext, which could be either XLive doc, XLive 1.2, or a GNU-PO text format. To give you an example, here you see the manifest of a translation request. You see the creator, you see the definition of the task, and package objects includes the description of the actual payload. And this is the response, where we again see who has initiated the task, and so we can track how the package was distributed in our virtual supply chain. And now you can imagine, when we look at our supply chain, how it works with traveling containers. A few things about implementation details. Of course, we could use a service-oriented web service approach, but I mentioned already there's also the idea of using representational state transfer, and REST approach. And this REST approach is the architecture underlying the World Wide Web, and this is yet another opportunity, because the difference in the two approaches are: the first one, SOA Web Services, focuses on processes, and the REST approach focuses on resources. So this also includes a different way of thinking about how we describe services. Because we focus on resources in REST implementation, we use HTTP as a transfer protocol and not as a transport protocol, as we do it in SOA Web Services. Here are some of the pros for SOA Web Services. They provide a many-to-many provider-consumer scenario. They could be implemented stateless, and normally they apply to a limited audience. That means the environment of a certain enterprise. SOAP and WSDL are to some extent a little bit language agnostic, so you have to see how you implement your enterprise service bus. And for the REST approach, we can also state that it provides a many-to-many provider-consumer scenario. It is inherently stateless. This is part of their specifications, and it would be for the public audience. For both approaches, versioning and documentation is very critical, because you have to maintain, when you go public as a web service, you have to see that the web services never break an existing implementation, so you have to be strict in your versioning. That means that when you use version 1 and you switch to version 2, you have also to ensure that customers using version 1 could be also use your web services. authentication is another issue that in both approaches is very critical. And because my time is more or less over, a general recommendation would be to implement a service-oriented web service approach internally where you are in the enterprise environment, and so you would use private, and private is in quote, APIs, and if you have to go public, like for example the Amadeus web services, then you use a REST approach. References for the Linport project and interoperability. Now, because the slides will be published, you don't have to write these down. You also have references for XLive doc, where we have the reference guide, we have XSDs and a lot of examples, and the same holds for TIP, the translation interoperability protocol package. So you get a lot of information on the World Wide Web. And before I close, there's one more thing, some final good practices. Don't start management until you have many services. So it would be an overkill to describe 2 or 3 services. Don't design all services first, so you have to see that this is an ecosystem that evolves. And last but not least, do not provide the infrastructure first, because you have to see what services do you have to define and to describe in your service-oriented architecture. Of course, this is a change in the enterprise, and therefore you need management support. And of course, you also need a budget for the long run, because a budget cut halfway would be a recipe for disaster. And this is the end of my presentation. Thank you very much for your attention.
You can use the data. This is working.
Thanks. We have some time for questions. About 3? I think so, yeah. Are there any questions? I have a small one. Like you made a distinction, but you didn't go into it. It might be a bit nitty-gritty. Between transfer and transport. Could you expand on that?
Yes.
Thanks.
In using HTTP as a transport protocol means you simply transmit data via the protocol and via the verbs or methods of the protocol. And in representational state transfer, you transfer information about the state in the representations of your resources. And that's the main difference.
Thank you.